Yeah, good evening, everyone. Everyone is able to hear me? Hope you're able to see the material that I uploaded, right? Everyone is able to see the material. Everyone is able to see the material that I uploaded. Everyone is able to see the material that I uploaded? Yes. Okay. So today, we are going to see we're going to see the another important tool. So another important tool called Git. So if you're able to see here, so we covered all the 4 tools. Oh, sorry, how many tools? We covered 5 tools. Now we're going to see the important tool called Git. So what is Git actually? So what is Git? So Git is a just 1 minute. Huh? So we covered actually 5 tools, 5 tools. Now we're going to cover the next tool called Git. So basically, what is Git? Git is a source code version control system. So basically, let us take, there is a project, for example. There is a project. Sir, I got a call. So Git is a source code version control system. Suppose what is a project? If I have a project, say there are different developer missions. So there are different developer missions. Say developer 1. So dev 1, sorry. Developer dev 1 mission. Developer 1 mission. It is developer 2 mission. Right? Say developer 3 mission. So developers will be working on their missions for this project code. Okay, in each of the developer missions, there will be project code, right? There will be project code. Okay. And I know it is not safe to save the project code in developer machine. Project codes in developer machine permanently, because why means, see, though the machine is provided by your office, there is not an issue. It will not be any compliance issue or anything. But because what happens if laptop crashes? If your machine gets crashed. So all the source code that you spent effort in developing this project, all the source code that you spent effort in developing this project, okay, will go in waste, right? Will go in waste. Because you're taken, say, some 3 months of your effort, and you have spent some effort in developing the project. And the code is there in your machine, but suddenly your laptop got crashed. So you cannot restore that also. There is no backup also. So that is the reason this source code version control system plays an important role. So basically, what is source code version control system is? So source code version control system is a centralized server. We can say is a remote server or a centralized server or an external server, where the source code of the projects, can be stored safely. Okay. So the advantage of this source code version control system is, say this developer 1 will do. See, in a project, it is not that one developer will develop all the pieces of the code, right? See, this developer one will take some parts of the functionalities and he develops some code. So developer two will do some codes. Developer three will develop some codes, right? So like that, each developer so will so each developer will develop his own part of the code. His own part of the code. And what you do, and this and a team lead or a tech lead will review the code. They will review the code and then finally will review the code and then finally pushes the code done by all developers to version control system. So what actually the team lead will be there here. So team lead or tech lead. So he takes this code, So he takes this code. So pushes. So what actually team lead or tech lead will do is, so he takes this code and pushes the code to a source code version control system, which is an external server. And how he pushes that all we'll see later. So for now, you can think like source code version control system. Source code version control system will store source code version control system. Yeah. Just 1 minute. I'm getting one call. Just 1 minute. Yeah. Actually, I shared you the Google Classroom link, right? Did I not share it? I shared you Google Classroom link, right? Just 1 minute. See, actually, I sent you this link. I don't know why you are not able to access. Okay. So basically, source code version control system is like so where it maintains all the code. It maintains all the code, right? Related to one project. So like that, it can maintain multiple project codes. It can maintain Yeah, some people are telling that they are able to join with the class code. Lokesh K, you can just check with that. Lokesh K, Javed Hussein. Just check with it because many people are able to join. I don't know why you both are not able to join. Okay. So it can maintain project code. It can maintain project code related to multiple. It can maintain project code related to, or it can maintain code related to multiple projects. Okay. So what will happen is actually source code version control system is a server. This is a server. This will contain the code related to all the things. And in addition to that, source code version control system If you see the name itself tells version control. So what do you mean by version control is, so multiple versions are managed. So that means multiple versions of source code are managed. So for example, I have an a.java. a.java. I have b.java. Next is c.java. Right? So what will happen is, so a.java, b.java, or c.java. So developer can, so for example, these files will undergo so many changes. Okay. So for example, a.java now initial will be having two methods. Later developer will enhance this code or will modify this code, and thereby the code changes will happen. So whenever developer pushes the changes to this version control system, so every change that is happening, so developer pushes changes to the code. So every change happening will create a version of the code, will create a new version of the code. And version control system will maintain the versions also. So this version control system version control systems will maintain versions also. I'm able to access this link. Why you are not able to access? So I'm able to access. I think you have to check with admin only, Lokesh K, because I don't have access to any of these things. So I think one of your friend is telling. Just check this. All right. So version control system will maintain versions also. Okay, where each version of the code will have different changes. Okay. See, for example, suppose I do some changes to a.java, b.java, c.java, and move to production. Okay, whatever the version control system, they are the latest versions. So what happens in the production server? So immediately what will happen? I'll roll back this. So I'll be having the older versions also of the code. So if some new versions are creating some problem, so immediately I will take the older versions of the code in version control system, immediately take the build and move to the production server. In that way, version control system will maintain all versions from the initial version of the code to the latest version of the code. So in that way, this is called source code version control system. Okay. And So basically, Git actually
Recording in progress.
so Git is a decentralized or distributed version control system. So Git is a decentralized or distributed version control system. Okay. So what do you mean by this is, suppose I have a, so now I have a Git repository, which is a remote server. I'll tell you what is GitHub and Git are same only, but I'll tell you what is GitHub exact difference. So distributed version control system. Now we have a project A. Say project A. This project A contains multiple Java files. So this project A contains multiple Java files, right? This is called remote repository. So this is called remote repository. Okay. Now we can actually take the complete repository into the developer machine. See, not only Java files, property files, property files, etc. Okay. Now I have developer D1 machine. Okay, now I have developer D2 machine. So now I have developer D2 machine. So what we can have is we can copy the complete remote repository to this machines, So when they are copied to these machines, these will be local repositories. Local repository. So this will be local repositories, right? So basically, that is what we call it as a decentralized or distributed version control system. That means we can take this complete remote repository and copy the complete local repository into these machines. Okay. So developer D1 machine, developer D2 machine. So I can copy this local repository. So when I say repository, what it contains actually. So basically, this is a code repository. Okay. This is a code repository. So this code repository contains multiple branches. Okay, this code repository contains multiple branches. So one is a master branch. Another one is a development branch. Another one is a feature branch. Right? Now, in master branch, we will have now a.java. These are called branches. I'll tell you what are these branches. Okay, these are branches. So these are all branches. I'll tell you what is this branch. I'm telling what repository. When I say remote repository means this is a code repository. Now, if I copy that to my machine, the complete repository, it will be local repositories. And these are branches. Now, each branch will contain multiple files. Say a.java. Just 1 minute, I'm getting on the call. So a.java. Next is b.java under master branch. Okay. Now, right. Now under a.java, there will be multiple versions. Version 1.1. Version 1.1. Next is version 1.2. Right. Next is b.java. There is version 1.1. And next version 1.2 like that. Similarly, development branch also will have the different files like a.java, all some c.java, b.java, like that. Under c.java, there will be versions like that. See, branches are like where different teams will be, or the same team will be working on different features. For example, say this code repository belongs to some banking project. Okay. Now, in this banking project, so when first we started development, we create one branch, development branch, and we work on those files. And when we move to production, we move that to master branch, and master branch will contain the production code. And feature branch is like once the code is moved to production, so any enhancements on the code will work on feature branch. Like that, there are branches. So in this way, for example, this development branch will contain the code. Branch will contain the code. Okay. Development branch will contain the code related to initial development. Okay. Or initial development. When you start the project, new project related to new development. Okay. When you start freshly, will contain the files, we can say, will contain the code or files related to new development. Master branch is the branch which contains the code, where branch contains the files or code, contains the code or files that will be moved to production in production. And feature branch is the one where will contain the code or files files related to. So feature branch will contain the code or files related to enhancements. If you want to do any enhancements, okay, once the code is moved to production, you have to do some enhancements. So for that, you'll get some support issues or something, enhancements or issues or fixing issues. Like that, we divide that into different branches. And each branch will contain multiple files, and each file will contain multiple versions. So this is what the repository contains. Now in the distributed version control system, this repository is called remote repository. And when you copy that to your local machines, those are called local repository. That means now this local repository will have all this structure. Okay, and once you can, so you wanted to, so once in the local repository, now you wanted to work on one branch, so you'll switch to that branch. So in local repository, we switch to one branch. So then we update the files or create new files, update the files or create new files in that branch and push to remote repository again. And push to remote repository. In this way, Git will work. Okay. So basically, GitHub is, suppose someone has asked what is the difference between Git and GitHub. Now in my local system, see first in my local system, that is my laptop or system, I create a code, right? Code, all the code related to the project. Okay. So first I'll do what I'll do. No, in my local system, first I create a local Git repository. Local Git repository. And how we'll create local Git repositories? We can download Git software. We can download Git software in this machine. Software in this machine. And install it, uninstall it. So once you install that, then you can run some Git commands. So once you install Git, you can run some Git commands. I'll tell you what are these Git commands. So Git command to create a local repo. Git command to create local repo. Right. Now, then you'll use some Git commands to the code that you developed in this project to this local Git repo. Okay, so what we'll do is, so we will use Git commands. So once Git is installed in the machine, so we'll use Git command to create local repository. Local repository. Next, add the code or files. Okay, that are developed in your local machine. In the local machine to local repository using Git commands. and then push the code in local repository to remote repository using Git commands. So we have different Git commands, I'll tell you. Now, push this code. So push this code that is present in local repository to your remote repository. This is a separate server. See, the advantage of this is even if your laptop crashes also, the code will be there in your remote repository, remote server. Okay, you'll push this code again using the Git commands. I'll tell you what are those Git commands. Now this is your Git server. So this is your Git server. This is your Git server. And there are different Git servers in the market. In that, one popular one thing is GitHub. GitHub is one Git server. Similarly, Bitbucket is also there. This is also one Git server. And similarly, GitLab is also there. So these are different third-party Git servers. So these are third-party Git servers. So using this GitHub or Bitbucket, we can have one remote repository created in that server and push all the code from local. So first, what we have to do? First, we have to install Git command. See, first, this is the first step. Next, this is the second step. Okay, once Git is installed in the machine, we will use Git commands to create local repository. And this is the third command. So what is third command? Add the code or files that are developed in the local machine to local repository using Git commands. Next, what is the next one? Push the code in local repository to remote repository using Git commands. So first you have to download the Git software. Next, create a Git local repository. Next, whatever the code that you developed here in your local system. Okay, you might have developed and saved in this code in C drive or D drive, some folders, right? C drive or D drive folders, right? So what you do, you copy this code from this, or you add this code to the local Git repo. And how we will add is using again Git commands. I'll tell you what are these Git commands. And once you add the code in local repository, then you can push the code in local repository to remote repository using Git commands. And this remote repository is some third-party Git servers. So which are GitHub, Bitbucket, GitLab. So we'll be using GitHub in our practicals. So we will be using GitHub in our practicals. Okay. So these are the things. So first, how to download Git software. Okay. So how to download Git software? See, Git can be downloaded Git download. So you can go here. You can download the Git. So this is the link actually. Okay, Git can be downloaded from this link. So first step, download Git in your machine from this link and install the Git. So you can use Windows or Linux or OS, Mac OS, and you download it. So once you install Git, right? Once Git is installed successfully, so once Git is installed successfully, so type Git command in the command prompt window or in the console. In the command prompt window. So if I go, I already installed Git actually. If I say Git, it will list some content, some commands. Okay. So if you get a message like Git command not found, then Git is not installed properly. Okay. So if you get a message, Git command not found, then Git is not installed properly. Okay. So once this Git is installed command, okay, then what you do? Create local repository, local Git repository. Okay, using Git command. Okay, I'll tell you how we'll create local repository. And then what we have to do, then add the code. Add the code from your workspace. This is called workspace, right? Somewhere in C drive or D drive. Okay, this is your workspace where your code is present. Okay, and add to local Git repository. Using Git command. Next, commit and push. I'll tell you this. Push the code from local repository to remote repository. And this remote repository is GitHub or Bitbucket. To remote repository, GitHub or Bitbucket or GitLab. Okay. So these are the steps we have to follow. Yeah, I'll tell you. Those Git commands, I'll tell you. Okay. See, anything that starts with Git is a Git command. After Git, you have to type the commands. I'll tell you what are those commands. So there are different commands. One command is there to create local Git repository. One command is there to add the code. One command is there to commit and push the code. I'll tell you what is this commit and push the code and all. So you have to install the Git. You have to download this. Download from here. Download from this Windows executable file. Just install it. That's all. You will get an executable file. Just double click on that. It will install. Okay, just download the software from this machine and double click on this. So once this Git installed successfully, we should know whether Git is installed successfully. Type Git command. Just type Git and enter. Suppose you get command not found, that means Git is not installed properly. Suppose if you're getting the message like this, that means Git is installed properly. Okay. Then what you have to do? Then using Git command, I'll tell you what is this Git command. Okay, to create a local Git repository. Similarly, using another Git command. Okay, this is another Git command to add the code from your workspace and add to local repository. This is another Git command. Okay. Next, commit and push the code from local repository to create remote repository. This is again using another Git command. Using another Git command. Okay. So once you have this one, you just download either Windows or Mac OS or Linux. You'll get this. Standalone installer. Here you can go here. You can go for standalone installer, 64-bit GPOD. Install this. I already installed it, so that's why I'm able to run the git command. So tomorrow we're going to see these two steps you follow. Then third step onwards, I will just tell you from tomorrow. So what you do is go to here and click on either your 32-bit or 64-bit. You click on the standalone installer. Okay, I think for your Sonar Cube, you should have Java path set. You should have path set in your environment variables. See like this. So you should have path set like this. So properties. So advanced system settings, environment variables, path. You should use this JDK pin. Okay. All right then. So tomorrow we'll continue then. So tomorrow I'll be explaining you these things. Okay. Tomorrow we'll continue this. All right then. Okay. Thank you all. See you tomorrow. See, you have to check with the admin only. I think Sunita madam or so. Okay, I'll inform. Okay. I'll inform. Okay then. Yeah. So thank you all. See you. Okay. Thank you all. See you tomorrow. Yeah.